Hello, hello. Welcome to the ML-Ephant Machine Learning API SDKs explained video for JavaScript. This is sort of a speed run from no code to a complete web app. It's a product generator. The product in question for today is a ice cream cone optimizer for that's based on the weather of the day. So a hotter day, larger ice cream cone holder. Yeah. So I hope you enjoy. And the boring parts haven't sped up. So I hope it's enjoyable right through the whole thing. So see you on the other side. Okay, right off the bat, API reference. We're going to go to the TypeScript tab. There's the npm install kittycat/lib command that we're going to run. Before we do that, we're going to create our own project. Naturally, we're going to call it something like my cool project. We're going to open that up. And we're going to start with going to the next.js website to copy and paste the create next app command. And the reason for this is because had we installed the kittycat library first, it would have gone into the wrong package.json because next.js creates its own when you create the next.js project. So here we are there, go to the front page, copy paste that. We're going to go through the short list of recommendations or the project configuration. We're not going to use TypeScript in this case, but you can if you want. Actually, our SDK was written for TypeScript first. So if you want to use it, go ahead. I'm going to fast forward a bit. This is just the setup. We're going to check to make sure that Next.js actually installed properly. We'll see shortly that it does. There we go. So we're going to close that. We're going to just set up a little bit of boilerplate. This is an endpoint that we're about to create to start off the bat, API/generate. We'll also come back to this later. It'll be a get endpoint that our Three.js scene will fetch. Before we do that, we're going to delete a bunch of boilerplate that Next.js has given us. Delete the footer, everything inside the main tags. We're going to give this a little heading, flavored ice cone generator 9001 for Ice Baby Inc. So that's the company we're making this little product for. And we're going to have the generate cone components. We're going to go see if that worked. There should be an error because, of course, we haven't made the generate cone component yet. So we're going to go back, create a component for generate cone. Then we're going to hop into that file. And we're going to, once again, write some more boilerplate. Lots of boilerplate in React. We all love it. Not really. Make sure to use the use client if it's a non-server side component. We're going to import it, and we're going to want to see if we get the OK message. There we go. Perfect. All right, on to the next step. We know that component works. We're going to slap in a button. This button will drive the request to the endpoint that we want. What's really going to happen is every time we hit that button, it's going to increment a little value. And if the value is above 0, then it creates a Three.js scene. And that Three.js scene will want to fetch the model. And that model is generated by ML-Ephant. So there's a cone scene. We're just going to create a skeleton cone scene. Once again, more boilerplate. Yum, yum. I'm thinking, what am I doing here? I'm going to go look up how to load a GLTF file through Three.js. Very simple. I'm just going to look at the example that meets my needs the closest. Here's one. I'm just going to copy and paste that, slap it into the project. We're going to put it into a use effect where it's going to initialize Three.js. And it will run that reinitialization every time there's a different model iteration, or if the canvas reference changes. Again, this is all really just to get to the end goal as fast as possible for demonstration purposes. But I mean, this could pretty much work also for a very basic web application. Here, we're just doing the typical React.js checking for reference is not null. And then we pass off that canvas reference to the rest of 3.js. So here, that's just the checkerboard plane. But what we really care about is this line here. So this line allows 3.js to load a remote resource. In our case, we're actually going to hit our local endpoint instead, which was API/generate. So we're back at the route. We're going to go see if things are working. Actually, we're going to go check out the generation endpoint first. We're going to copy and paste the code snippet, fill out the endpoint logic, paste it in. Very straightforward. We're going to call this create. We don't need the KCL version or the project name. They're not necessary, although it does help with generations. It gives the model a bit more context about what you're generating. Here, we're going to turn prompt into an argument, so it's easy to work with. We also need to make sure to be returning the response. In all the API examples, they actually just output the result. So be sure to change that. You might get caught up on that. Now we're going to log in to get a API token. Very straightforward. Oh, before that, so we've logged in there. What we're doing now is we're checking to see if the prompt that we want to use is going to be a valid prompt or a prompt that generally gives us what we want. So going to app.zoo.dev or using the Zoo Design Studio is a great way to quickly test prompts or to generate data that you're going to use in your application. So there we go. They generated a cone exactly as we wanted. So we're going to copy our prompt, which is put into the KCL code. And we're going to just put it here. So now that we've verified that it works, we're going to have our endpoint return what ML-Ephant gives us. And that will be fed into our little front end that we're building in next.js here. You can see I'm trying stuff out. I'm forgetting to import a couple things. Typical dev that's not using TypeScript. I'm installing some missing packages, and then there we go. Finally, there's the scene that's loaded. That's a 3.js scene with that checkerboard pattern, like I had mentioned earlier. And there we go. So this is the API token is missing. Because we've logged in to app.zoo.dev, we don't need to log in again. Instead, we can go straight to our account. We can go to our access tokens. We can generate a new API token for the project. Copy the token. In this case, you're going to see my token. Obviously, don't share your own token. If you go to try this and use this token, it will not work. So don't be surprised if you go and use my token and it doesn't work. And voila, a wall of freaking text. So this is the output of the generation. We can see the status is completed. It gave us a bunch of model data in a few different formats. And now I'm going to add an extra instruction. Actually, before that, I'm going to show you how the jobs are actually typically get queued and they don't always return like that so fast. So if you end up sending off the same prompt twice, it becomes cached. So in order to access, there we go. So in order to access the status of the generation, you need to hit that endpoint, the async operations endpoint. So we're going to go there. We're going to go copy the request or the function that we need to make the request. And then we'll simply pull that endpoint over and over until the status becomes completed. So there are three states. There's the queued state, there's the in progress state, and then there's the completed state. And that's the one that we care for. So once again, be sure to return the response. We renamed it check. We changed it to have a ID arg instead. And now this is the polling logic. And we're gonna really fast forward through this part because this is just me failing for about a good 10 minutes trying to get the polling logic to work. It's a mix of promises and set timeout. Oh yeah, be sure to use base64 URL decoding. It's different from base64. So I got caught up on that as well as I was doing this. Really be sure about that because it will not decode properly. So eventually we get the polling to work. It waits 1 second before every request. And there we have it. So that is the application properly polling every 1 second to see if the model is complete. So now we're going to add a little bit of spice. We're going to hook into the Google Weather API. We want to get the temperature for today. So we're going to click into here. We're going to check out the API. Very simply, we're going to take this URL to request the weather. No SDKs or anything. It's very straightforward, which is really nice. Saves us some time. Saves us some headaches. It's the way to do it. Of course, location and whatnot could be fetched in other ways. We're going to also pull in our Google API key through the environment, just like we do with the Zoo API token. And again, this is going to be used to determine how big the cone becomes. So the hotter it is, the bigger the cone. Colder it is, the smaller the cone. Gotta optimize. Optimize. So we're just gonna fast forward. This is the temperature average between the lowest and the high of what it feels like, because what humans feel is probably better than some objective value. I'm just verifying that these are the actual names. Add them in the max, divide by 2, got the average. Now we're gonna add on an extra instruction to our prompt. It's kind of like a system prompt plus whatever, like the user prompt, right? And this extra instruction is just gonna say, for the circle that was larger, and for the height of the cone or the distance, adjust them such that the volume is optimized for what the temperature is for that day. And I actually just let the machine learning model determine what that value should be. So it's kind of fun that it's vague, right? Like, what will it give us? So we're gonna try it out, see what happens. This is me struggling to get a Google API key because their dashboard is just so good. Without fail. Once again, if you use the API key, it's not going to work, so don't bother. And we run it. And I believe it fails. I forget if it fails or succeeds the first time. Oh no, so it worked the first time. So there we go. So this cone again is based off the temperature of the day, the height, and that's it. Very straightforward. So I hope that was fun. You now have the ability to create your own ML generated models for some product business. And yeah, if you have any more questions or need to know more, you can join us at our forum. The links to that is in the video description, or you can check out docs.zoo.dev, or you can check out our GitHub, which has tons of code that is used in our products. We really care about dog fooding our own solutions, so really go check that out if you want an even deeper dive. I highly recommend it. That's where I actually go a lot of the time to see how something is used. So have an awesome day and go check out our other videos.